Yes, sir. Thank you, sir. Bye, sir. Good evening, sir. I was the first.
Hello,
I finished the homework, sir.
what's
Good
good?
evening, sir.
Good evening. Am I audible?
Okay.
Yes, sir,
sir.
we can hear you, sir.
I came first.
No, you joined before.
No,
us.
I actually came first. I
No
left
one
the
can
meeting and
believe
I
you.
came. Dude, actually,
I don't know what.
sir,
No,
I
I
came. Sir,
didn't.
I came like 30 seconds ago only, right, sir?
Yeah, you came first.
Sir,
They,
but 30 seconds ago, sir, because last class was still going on 30 seconds ago. That means technically he's cheating.
how's the cheating, sir? It's called joining in time and still
Not joining
focusing in
time. You
other
joined
class.
before 30. You joined 29.
Sir, I'm ready for the numericals, sir.
All right.
I
Oh,
know nothing.
yeah, a new update is there. Before the numericals, we'll be doing the next chapter because
Sir.
by mistake, what I did, I made the question paper jointly, considering these two chapters as one.
So
Wherein
this
no,
test is on pressure, atmospheric pressure, and the next chapter.
and the next chapter also,
No,
yes.
you're not.
Karun, if you're speaking, we cannot hear you.
Dude, I think it's
Oh
not
no,
your mic problem.
energy.
It's your
No, it's not energy.
trachea problem.
Yeah, what?
It's your vocal cord problem, dude. Is
Oh no, we have
am I
asked his
audible to him?
principles and everything. We can hear you, the Sankar. We are just feeling to
No,
ignore
I'm
you.
telling, can he hear us?
He says he can. So next is upthrust in fluids, Archimedes principle, and flotation.
Right.
So this is like
Sir, this chapter is very easy, sir. I mean, not the fifth one. I mean the fourth one. Pressure.
It was not containing all those questions which I accidentally made for your test. And then when I saw the next chapter that I'm going to teach you, I realized
Sir,
that I have put up both the things.
sir, how can you mistakenly create an entirely different question paper, sir?
this is like 13
No,
pages long. So
actually, the thing is that now, uh, when I used to study, then both the chapters were one. Pressure in fluids and atmospheric pressure used to be just one chapter.
yeah, Tarun, we don't care.
Bro, why the
Tomorrow,
calm
that's
there.
a joke. Hey, you do that, you shut up. So the
There
test
used to
is
be
in
one
both of
chapter.
these chapters, right, sir?
Right. Now the test is in both of these
What about
chapters.
numericals?
Both
It's
are quite.
also
Sir,
done.
in our
See,
textbook
the
they gave
chapters that we
uh,
did right now, they contains very less numericals. That was one of the problems.
There's
Second
nothing,
thing,
sir. Rho G, it's what is it?
rho
exactly,
GH and
exactly,
P is equal to F by A.
It's the
exactly,
same
exactly,
thing. You
exactly.
just Rho
So
G is
that
derived from it. Yes, sir.
that's where I did the mistake. And in my time, I used to study both the chapters with one. So I thought that I have to teach a little bit more, and something is still left. So when I saw that chapter portion, then I got to know that no, it's nothing left. It's a new chapter. So that's why we'll be dealing with this chapter
But
today.
then how will we finish this chapter before
Sir, you remember
9 a.m.?
what chapters you did in your ninth standard, sir? Great, sir.
All of
So
these.
my sister forgot what she did yesterday, sir.
All of
What is this,
these.
sir?
Okay. So I did nearly all of these chapters in my class 9. That's why I was a little bit confused.
Oh, it's ICC. So you were also in
Right.
ICC?
No, I had CBSE. But the
Oh,
chapters were same, contents
CBSE,
were different.
yes,
Contents were
sir,
different.
because
time. Okay.
All right. So we'll be starting with upthrust in fluids. This is very interesting, very realistic.
Sir, more the number of numericals, more the number of interest.
Exactly.
I mean, both of these
Fluids,
chapters, including only there's so much theory, not numerical.
Archimedes principle.
Evening, sir.
Oh, look at
Good
that.
evening. And flotation. So this is something to be
Hello.
like,
Oh yeah, buoyancy.
yeah,
My
exactly.
favorite topic.
What
Yeah,
is
So
it?
this
Congress,
is
you
really
can
interesting.
Congress. Yes,
No.
sir.
Ah,
Very.
now I can hear.
See. The first topic, without wasting any time, we'll be dealing into it. So the first topic that we'll be digging into is what is upthrust?
So like the thrust in
Sir,
upward direction.
force in the upward
Force
direction.
applied upward.
I said it first.
Force
Exactly,
in upward
exactly.
direction.
Am I audible
The
now?
up,
Everyone is able to
yeah,
speak.
you're
Oh
Thrust
my
in
god.
upward
audible.
direction.
Normal
That is
thrust is.
You're
Sir,
audible,
thrust
Salim.
is. Why is thrust is scalar quantity, sir?
Thrust is not scalar
scalar
quantity.
quantity. Thrust is not a scalar
Sir,
quantity.
what?
Pressure is only a scalar quantity.
The pressure is a scalar
Oh, yeah.
quantity.
Sir,
Thrust
Yeah,
is a
I think
force.
how's pressure a scalar quantity, sir?
See, pressure is an extrinsic quantity where it gets divided with force upon area. Force is also a vector, area is also a vector. So when two vectors get divided, then
my
becomes a
God.
scalar
Oh,
quantity.
yeah,
This
sir.
you'll
So
study
They can
later.
only
mathematics
be divided.
said
So they can only be divided when they are of same direction, right?
No.
No?
Actually the thing is
it
that
does have to be vector.
force, let us say that force acting like this. Let us say that
Yes,
force
sir.
acting like this, and this is area. So area vector is in like perpendicular direction. This is area vector.
Yes, sir.
Whatever area is there, the perpendicular to it is its vector
But
direction.
isn't length
Sir, but
so
how is area a vector,
uh
sir? Like,
Area is a
length?
vector. Area is a vector.
how,
Area is a
sir?
So
vector,
what
Because
if
and
in a
force
normal
comes in
it's
like
like
slanting,
opposite.
sir?
It's like
So
it's like
what if
Newton's
force comes
third
like
law.
slanting, sir?
even that can be a case. Slanting force can be a case to
Then how
contradict
will the
you only.
vectors get cancelled, sir?
See,
Thrust is
vectors,
always perpendicular.
that doesn't mean that, like, I'm not saying that vector will get. What I am saying that vectors, if two vectors are divided, then the resultant is a scalar quantity. Not always, but 90% of the cases.
Sir, but how is area a vector, sir? It shows no
Yeah, it's a
direction, right?
vector. You know that cross product and dot product. You don't know.
No,
You'll
sir.
study it later.
Sir,
Then you'll study
dot
it
product
later.
is if you keep one dot between two
No,
numbers
no.
and
Yeah, that is different, but you don't know about that detail. So study about it
not
later.
in detail.
So our teacher said whatever given in the book you learn, sir. What?
The upward force exerted on a body,
When we ask a question, she'll tell, I'll tell you later, and then she'll forget it, I'll forget it.
that happens. That happens.
And then
By
Kongwe will
fluid,
be sitting next
Always.
to me, he'll tell that she itself doesn't know that. Why are you asking her?
it is submerged. Actually, everything has got a reason, but I cannot explain it to you beside explaining more of the details into it. For example, if you want to know why area is how area is a vector, so you need to know about cross product.
Sir, why do
What
you
is
draw rho in
So
that
that is a
in
good
like a
reason,
S
sir.
way, sir? Why do you draw rho in like look S
Yeah,
looking,
sir,
sir?
we drew it as a P in school, and then
Yes,
you drew it
sir.
as a very fancy
S,
this
sir.
one?
Yes,
Latin word.
sir.
Actually, this is the original denotation of density. P is not the density.
No, sir. It is
Sir,
like
like somewhat like that, sir.
Yeah,
Row looks
somewhat like
somewhat
that
like
it
that.
is.
yeah.
Sir,
Somewhat
but
like
if
that.
A
you'll
fancy
Google,
version of
sir, if
P.
you Google, it doesn't look like that, sir. It's
Okay,
like a P, but with
Sir,
the
That
bottom
curly
is
the
P.
a
sir,
circle.
the P we do is we have to remove the stem before the loop, sir.
Yeah,
So, but if you won't get marks, right? If I do this in the exam.
Yes, sir.
yeah, that will get. It's called. So okay, focus here. This is very realistic chapter. More realistic than force Newton's laws of motion because this is what you see. It's called the upthrust.
Yeah, but
When
I don't
you feel
usually
things,
move anything up.
when you feel the physics, that you know something about the physics, that you can be a scientist in the future, when you can relate it with your sci-fi. Have you ever seen a sci-fi?
Yes,
Yes, sir.
it's like scientific movie. There's a sci-fi
Science
movie.
fiction, right?
Yeah, science
Science.
fiction.
Exactly. See what
Even
happens
like
there.
Marvel
Not
I'll
is a
just
real,
give you
sci-fi.
the reason. I'll just give you the
not
reason.
real.
See it. how does body floats? How does flotation mechanics work?
Density.
Yeah. How density comes into picture, how
Buoyancy.
volume comes into
Sir,
picture,
because there's
how
air in
buoyancy,
the whatever thing.
Because
how
of the
how
buoyancy.
okay, everybody please, for the next 10 to 15 minutes, I need no one to speak anything. Focus on,
Yes.
otherwise I won't be like
Just
explaining the
mute.
same thing again. Right. So this is
Mute.
very important. If you understood it, you'll be able to solve all the problems. And if you did not, you'll ask me again and again to explain the same thing. Now see there, what happens, how and when a body floats. Okay, thing is that the pressure always increases with height. Okay, pressure always increases with height. Let us say this is the mean sea level. This is the I think my eraser, right. So let us say this is the mean sea level. Okay, mean sea level means what? Where the sea exists, right? This is the beach, right?
Like it's the
This
same
is
in
the
all.
beach, and this is the height below the beach. This is the
Yes,
height
sir.
below the beach. Okay, and this is the seabed. Seabed. Seabed may extend from 10 meters to 11,000 meters. That is the Mariana Trench, if you know that,
Yes, sir. We know.
Yes,
right?
sir.
Now, and this is the atmospheric height. This is the last height of the atmosphere. So, at the sea level, we all know that the pressure that has been exerted by the air is nothing but rho g h. Say yes or no,
Yes.
Yes, sir. Yes, sir.
right? I'm writing it as
Is it
capital H.
only me or like is the screen lagging a bit?
No, it's good. It's
Hey, when you
working
share
great.
the screen, it'll be like that as
Okay,
well.
you quickly rejoin. I'll be waiting for you. Quickly rejoin, Pangui.
Sir, before
Yes,
he
sir.
returns, can I just
Quick,
ask
quick.
bro?
Yeah, go on.
Sir, how does pressure increase by height, sir? Pressure
In above the
increases
mean
with
level
depth, right,
surface,
sir?
above sea surface.
I'm taking the height from the top of the atmosphere. I'm taking the height from the top of the atmosphere. This H is increasing this way. Now is it
Oh,
increasing?
okay,
So
okay.
that has like the height decrease. I mean, decreases, pressure
Yeah,
increases
if
like
you're
that.
measuring from the base, if you're measuring from the surface, then it is decreasing with the height. That's
Yes.
correct.
Sir, so you're taking from the topmost
Yeah,
height and then
I'm
coming
taking
But
from the
it's
downwards.
top.
like what you said underwater. It's pressure increases with
Yeah,
duration.
I'll be going to that. I'll be going to that. I'll be going to that.
So Kongu will join, sir.
Congo,
You
is
can
it fine
continue.
now?
Yes.
Congo, is it fine now?
I think he won't be able to see the screen for 10 seconds, sir.
That that computer.
Congo,
Hello?
please respond fast.
So I think you can hear us, so you can continue.
Oh, that would be difficult then.
Sir, someone's typing, sir.
I am typing.
Yes, I can
Oh,
hear
okay.
now. Okay, sir. Whenever I want to
Okay, that's
rejoin
fine.
fast, it won't happen. Whenever I don't want, it'll happen.
Can you see
Yes.
it? Can you see the screen? Shall I start?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Right. Tarun, are you there?
Sir.
Okay, good. Now see there. Now, same thing happens with the depth of the ocean or water also. So whenever you'll go inside the water, the pressure at, let us say, again a height h will be the same row of water. Now it was row of air earlier. It was row of air earlier. I should write it that. It was row of air G into H. Now it is row of water into G into H. So there are two kinds of forces that are being acted at this particular plane. One is called the gauge pressure or gauge pressure, what I use it. Second is the absolute pressure. I'll define it later. Absolute pressure. Absolute pressure is total pressure that is being acted. Total pressure. Gauge pressure is the net pressure. Okay, so total pressure means what? So you can say whenever a man dives to this depth h, small h, okay, inside the water, so he is being acted upon by two kinds of forces. One, the height h of water above him, and the height capital H of air above him. So this is called the atmospheric pressure, and this will be the water pressure. Okay, so atmospheric
Excuse me,
pressure plus
sir.
water pressure. Yeah.
Sir, don't talk.
Sir, why can't we take the average for the entire height, sir?
Average.
Average.
Sir, like rho. Like, why can't we take
Why would
rho
we
for
take
the entire
average?
height?
Why would we take average if we know everything in detail? Row of air, you know that is 1.24 something, and row of water is what? 1000 kg per meter cube. Just that we feel the atmospheric pressure because it is having great extent upwards. So that H increases and we feel a pressure of around 10 to the power 5 pascals that we calculated, isn't it?
Sir.
So that density does not matter in case of air. That height is really high. That is creating even the small density. Like for example, if you put over just 1 gram weight, if you just put 1 gram of rice over you, and you keep on putting for 10 kilometers upwards, wouldn't that be great?
So you like
Yes, sir.
crumble over, so it's that much.
Sir, can you repeat what's Gog?
Yeah. Pardon?
Can you repeat what's Gog?
What?
I cannot hear that.
The number one which you have written at the leftmost.
Gauge
Gog,
pressure.
etc.
Sir, what
Gauge
is the
pressure
word
is
after or, sir?
absolute pressure. Where
Buoyant.
or is there?
Buoyant.
Buoyant. Buoyant. Buoyant.
Buoyancy. Yeah.
Okay. Focus here. I'm still not
Continue.
complete. Please don't interrupt. So total pressure at that particular height inside the water is what? Atmospheric pressure plus pressure due to water plus pressure due to water. Now,
Yes, sir.
what is gauge pressure? Gauge pressure is net pressure. Generally, we remove the atmospheric pressure. Generally, we do not consider the atmospheric pressure. Just the water pressure will be gauge pressure. Just the water pressure will be gauge pressure because atmospheric pressure we generally neglect because that is something we can consider. We can leave it or we may not consider because that is we are inhabited to, right?
Yes,
We
sir.
can what we can uphold the atmospheric pressure. That's what I can say. But if you go deeper inside the water, your pressure exerted due to the water surface will be so huge that your cells will burst. That's why we wear special suits, and the submarines are made so tight. Are you getting my point?
Yes, sir.
So that they
Yes,
don't
sir.
burst. And you must have seen the recent case that happened with the Ocean Gate
Yes, sir. The
submarine.
The
Titanic.
Titanic
The Titanic.
Exactly.
submarine.
You know what must have happened there?
Would have like
Even
Yes,
if they
sir.
would have
Pressure was
broke
too
one,
high to
exactly,
handle.
even if they would have broke one windshield of them, one windshield of theirs, that will create like so much of pressure on themselves because earlier what had happened? Earlier they had a very good submarine. Submarine was tightly packed like this, isn't it?
Yes, sir.
And
Yes,
they
sir.
had a windshield, and that windshield was created so to attain such a great pressure. But if it was broke due to accident, so all of the pressures will be exerted on the person sitting inside it, and they
Yes,
can
sir.
feel a pressure of around, I should say, around 1,000 elephants above it just at an instant, and they would
Oh
have
my.
died
Like,
within seconds. Within seconds,
It's like them in
saw
say
a video about
hydraulic
that.
press.
They
I saw a video about that.
actually died in 1 millisecond, sir.
exactly within
Hey, stop
seconds.
blabbering. How do you know? Chumma,
Actually,
don't tell.
No, no, I saw a video.
I
Not
read
within
the
seconds.
entire thing
No, that
on
has not
Chrome.
been determined yet. That has not been determined yet. They are still working on it. But the thing is that this
I
is
know
the
if they're
most
dead.
probable. This is the most probable theory that they said. I read about it.
Be
So this is
carried by
true.
movement also.
So the death will not be painful.
Yeah,
They
you
feel
may say
Because
that.
painful
You may
and
say
then
that.
like the
You
speed
may
of
say that.
your receptors are not fast as the pressure you feel.
Exactly. Earlier, people were saying that they starved to death with due to the lack of oxygen. But then a scientist came into the picture and he said that no, this may not have happened because
They
pressure was not
exploded.
considered earlier. Pressure would
Yes,
be
yes.
so huge
We're moving
that
off
you cannot
topic.
feel it. Now,
Yes.
okay, back to the topic. Okay, now the thing is that yes, if the pressure is there inside it, so have you ever asked a question that why is it not pushing anybody downwards instead? Why is not pushing anybody rightwards or
Sir, because of
leftwards?
the
Shut up.
yes, sir. Because like no, sir, as why da?
Okay,
Yeah,
let me answer first.
No, I didn't
Thing
ask
is that
anything.
water has a property. Water has a property that it exerts. You must have studied that. Water exerts pressure in every possible direction. Yes or
Yes,
no?
sir. Yes, sir.
Water
Yes, sir.
exerts a pressure in every possible direction. So now let us come to this picture. This picture is this body is partially submerged. Okay, it has not sunk to the bottom, and it is not like floating at the
Suspended.
top.
Suspended.
Yeah, it is suspended. Very good. That is a perfect word. Now the thing that is happening here. What color should I use?
Gold. That sparkly thing.
That you won't be able to see that. Green, I think, would be
Sorry,
better.
it's
Now
very
see
good,
here,
sir.
Oh,
pressure here at this point. Pressure at this point will be in this direction, 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 right?
yes,
Yes,
sir.
sir.
And
Yes,
pressure
sir.
here at this point will be in this direction, this direction, this direction, this direction, this direction, this
Will
direction,
cancel
and
out.
this direction, right? Now, what are the pressures that are predominant there? What are the pressures that are predominant there? This is
On
of
the
Sir,
no use,
upward
this is
pressure.
of no use, this is of no use, this is of no use, right?
Yes, sir.
same goes
Here,
for
this
the
is of
bottom
no
pressure.
use, this is of no use, this is of no use, this is of no use, right?
Yes, sir.
Yes, sir.
Agree, everyone?
Yes, sir.
Yes, sir.
Yes.
Now, let us calculate the pressure at this point, pressure at this point, and pressure at this point, right?
Yes, sir.
You
Yes,
don't
sir.
say that now pressure has been like, sir, you should like divide the pressure. You cannot say that. Even the pressure is P here, pressure is P here, pressure is P here. Whatever pressure was there, everywhere it was P. It was not to be divided. Understood?
Yes, sir.
Right. So at the surface, the pressure was P atmospheric. Agree?
Yes, sir.
Yes, sir.
That we know that is constant 10 to the power 5 pascals. This height is small h, and this height is capital
PH.
H. Agree?
Yes,
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 sir.
sir.
yes,
I'm
sir.
just removing these out because I don't want to change the page. That will be difficult to understand then. Now, pressure at point 1 and pressure at point 2. So
So you can
pressure at
erase
point 1.
the definition of
Canada.
upthrust also, sir.
Okay, that's it. Okay, pressure at point 1 will be what? P atmospheric plus rho of water into G into small h. Yes or no?
Yes, sir.
Yes, sir.
Everybody.
Yes, sir. Yes,
So
sir.
Yes,
where,
sir.
Like
where is
total
P1, sir?
At the top.
top.
At the top, see here, I marked the points. This is 1 and this is point 2.
Yes, sir.
Tarun, understanding? Right. Now, what is pressure at point 2? That is again P
Again,
atmospheric
P atmospheric. So atmospheric
plus
is
rho
neglected,
W
right,
G
sir?
capital H.
Yes,
Huh?
sir.
So atmospheric pressure is neglected, right, sir?
No, we don't neglect it. When we are calculating the gauge pressure, then we just think that atmospheric pressure is already there and we just see the extra pressure that has been acting upon there.
Yes,
Okay.
sir.
And when
Sir,
we measure
W is
the
the weight of
absolute
that
pressure,
rock, right, sir?
No, it's the water.
where is the W?
The rho water. Rho
The rho
W.
W.
Rho W means rho of water, density of water,
No,
Oh, okay. Density of water.
1000 kilogram per
right?
liter.
With small W, like at the bottom of rho. Okay.
Yeah, that was a subscript. Now,
Perfect.
do you think that P1 is greater than P2? Tarun will answer. Tarun, do you think that P1 is greater than P2? I cannot hear you.
You didn't say anything.
He asked what?
Sir,
Tarun, do you think the pressure at point 1 is greater than the pressure at point 2?
no, sir.
Why?
Because the pressure increase in them.
Okay, that's good. Exactly. And that's what we can see in this equation, where h is greater than small h. Yes or no?
Yes, sir.
You can
But
see
rho
this in
will
this
change.
equation.
Won't change, right?
Why rho will change? Density
Sir.
of water remains constant throughout. It is in air that rho changes, that we take the average. Air density decreases with height, but in water, it is water everywhere. Isn't it?
Yes, sir.
But still,
It
sir.
Yes,
Yeah,
sir.
right.
how,
Yeah.
how it would change?
No, sorry,
Like,
nothing. Now I get it.
is the water at the top of your bucket different from water at the bottom of your bucket?
But in the there's dissolved substances like oxygen, carbon. Okay,
That is
sorry.
uniformly dissolved. That is uniformly dissolved. It is not that you will get oxygen at some point and carbon at some point. Okay, I've entered water in the Pacific Ocean. It is more of carbon dioxide. No, it is in the Indian Ocean. It is more of oxygen. It
I
is not
drink
like
one
that.
and then die.
I
It
added
is
oxygen
uniformly
water.
distributed. It is uniformly distributed.
Sir, it's
In
like
air,
how like salt is uniformly distributed all over the
Please
ocean.
stay.
exactly. Now see here. You can see that P2 is greater than P1.
So
Yes, sir.
Where will the net force be? Net force
bot at the sides,
upwards,
bro.
isn't it?
Yes, sir.
Yes, sir.
The below
But-
force is greater and it is projecting upwards. And the
The Earth
above
is
force
still
is projecting
suspended.
downwards
Sir,
with the lesser
what
force.
is net force, sir? What is net?
Net force
Water
means
pressure.
like what?
Water
Net pressure. See, there
Sir,
are two
like
pressures
what is
acting.
net?
Explain that.
NET.
Net, NET. I'm not written NET.
Like telling your net worth, your net
Yeah,
payment.
net worth, like that.
Yes, sir, but what does net
It means
mean?
like current.
Your
Okay.
current
See,
Okay. I
see,
get it.
from the below you were getting P2 force. From the above
Yes,
you are
sir.
getting downward P1 force. So ultimately you are getting P2 minus P1 force,
Yes, sir.
isn't it?
Yes.
Somebody is pushing from downwards,
Like
from your below
overall
to
current.
upwards.
But
Let us say that.
sir, net force should not be P2 minus P1. So it should be that rho WG small h minus rho WG big H or rho WG because the
Exactly, and that is
atmospheric
P2 minus P1 only, na.
but atmospheric
Yeah, that
pressure
is.
is added for P2 and P1, right? So atmospheric should be negligible.
But
Both
it
will
does
get
not make a
subtracted
big.
also after.
It does not make
If you will
much difference,
subtract
sir.
P2 minus P1, this will also get subtracted, and ultimately will reach here only. Do that.
Oh, it doesn't make a difference.
Do
Okay,
that.
yeah. Yes, sir.
Okay. So net force is upward, and this net force is termed as buoyancy. This is the exact feeling of buoyancy. Now, did you understand it? Why buoyancy
Sir,
happens?
but isn't gravity also there, right, sir? It will pull
Exactly.
the
That will consider.
object downwards.
See, that is the tendency of the body to go downwards. We were studying about why water applies the force upwards.
Sir, but that body just does not like just in the middle of the water. It will go down because of
I'll
gravity, right,
discuss
sir?
about that. I'll discuss about that.
Pressure is greater than the
When body will be floating on the surface, when body will sink down, when body will be
so
suspended
it's like
inside
a
it. That is
game of tug of war, but like whichever side is
Physically,
stronger, it will go in that
in physics
direction.
terms.
first. Did you understand what physically buoyancy is?
Yes, sir.
So
Yes, sir. So I have
Okay,
a doubt.
this nobody. Yeah, go on.
So why can't it push the object in other directions, sir? Like towards the side.
Okay,
So
okay,
that
yeah.
point
equal
P
equal
itself.
Okay, I'll tell you. I'll tell you. Even that has an answer. Now see here, everybody. Again, quite. So pressure will be at this point also. Pressure will be at this point also. Pressure will be at this point also, and pressure will be at this point also. Similarly, on both the
No, sir.
sides.
No, sir. That's not my doubt, sir.
Go on.
No, sir. Actually, I'm asking that. Like the same point P2 also exerts force in the other direction, right? Like
will be
towards the
more
Okay,
left or
resistant
this
on
somewhere.
Earth.
side, this side, and this side.
Yes, sir.
Now see, this is something to be called from resultant force. You must have studied it. What happened? Hmm. See, if you are here, okay, you have two of your hands, and you have been tied with a rope.
There
I
are some
am
drunken
pulling
hands.
you this way. Sankalp is pulling you this way, and Nitish is pulling you this way. Where will you go? This way only,
I'll
na?
tear apart.
Yes, sir.
No, sir.
Because
Oh, yeah,
Yeah,
why?
because like,
yeah.
oh,
So let us say that
yeah.
this is F, this is theta, this is F, and this is also theta. So this F has got two components. One along this F cos theta, this also F cos
Like
theta,
Oh,
variable
yes,
value.
sir.
and this one F sine theta, and this F sine theta. So lateral forces gets cancelled, equal and opposite.
Sir,
Yeah, but if
what?
they're not equal, it depends upon the strength.
Oh,
I mean,
I get it, sir. I
okay,
get it,
equal.
sir.
Sir, I don't get.
You
I
already-
don't get it, sir. What is F cos theta and F sin
The
theta?
force vectored by me and Tarun.
Sir, what
What
is cos,
happened?
sir? What is cos?
This was the F. at some angle from the straight line. So this f has got the two components. We used to do this now. One along this and one away from this. Whatever we have along with the theta, that is the cos component. And whatever the side that doesn't contain theta, that has the sine component. Didn't we do this?
So we
No,
did this.
sir.
Okay, we didn't. This is
We
part
didn't.
of the
Why
class
did you do
11.
this, Raj?
Class 11.
Summa don't tell
Indeed,
me.
you
Did
do.
this. We did
Okay,
this.
Then would
okay,
have we
okay.
done it,
You
sir?
guys weren't there.
Ah,
Okay,
man.
okay, okay.
I attended one class. I
Wow.
don't know that time. Chuma, I asked
See,
the
see,
doubt.
see. This is F, this is F, and I'm pulling you with this force F. So this F is with at an angle theta, and this F is at an angle theta from the vertical, right?
Yes, sir.
So
Yes, sir.
this has got two components. This is inclined. I cannot solve it. I cannot take into picture. What I'll be doing, I'll be resolving it. How I can resolve it? So what if a projection of it this way and perpendicular to it this way? All right.
Yes, sir.
Are you getting my point?
Yes, sir.
Yes, sir.
So instead of writing this f, I can take a component of it on this side and I can take a component of it on this side.
Yes, sir.
What will happen after that? Instead of writing this f here, I can write this f as f cos theta this side and f sin theta this
Sine
side.
theta.
What
But
I'll
how?
think
Why
now
does
that
why does
yeah, I'll tell
sine
you,
and cos come here, sir?
I'll tell you. Let us say
Theta
this is a
opposite,
coordinate system,
adjacent, like that.
and I have one force here and another force here, f, and I have to take the resultant of this force. I have to think where the object will go now. Okay.
Sir.
So what I'll be doing, I'll be taking this angle as theta. So if I take a projection of this on this particular x and y coordinate, generally if something is inclined, we like project it on x and y coordinate to make the calculations easier. Think why I'm telling you. See, whatever. See, if you take the cos theta, this length x we don't know. So cos theta will be what? X upon f.
X upon f.
Yes, sir. Yes, sir.
X will
Yes,
be
sir.
f cos theta. So this is nothing
Yes,
but f
sir.
cos
X
theta,
will
and similarly this side will be f sin theta. So what I'll be doing now,
Oh, yes, sir. Yes, sir. Yes, sir.
I'll be considering instead of this inclined force that is not of any use for me, I'll be considering that is a resultant of two force, that is f cos theta this side and f sin theta this side. Now what do I have? I have a net force. I can subtract this now. This is equal and opposite. Like this is opposite, not equal. So let us say that f is greater. So now I have only two of the forces. One is this way, f minus f cos theta, and another force is f sin theta. Agree?
Yes, sir.
Yes, sir.
Yes, sir.
Sir,
Mm.
Depending upon the theta.
So
what
now
is
how can we
cos?
calculate?
The cos is the hypotenuse by.
Adjacent side
This
by
is by
hypotenuse.
hypotenuse.
Yeah.
Base by hypotenuse.
Yeah, base by
This is the same
hypotenuse.
thing.
If you
Yeah.
forget these things, then how it
If
do?
sir, it
No,
depends
sir.
upon
It
That
the
depends
theta,
upon
sir.
where the theta is.
If it is the
So
top.
now how can I find the resultant? You know that if 5 is there and if 4 is there, you can find the resultant easily by under root 5 square plus 4 square. Yes or no?
Yes, sir.
Yes, sir,
Similarly, we
it's
can do it
9.
here. 5 f minus f cos theta whole square plus f sin theta whole square. And I also know that my resultant force will be somewhere in between here. So
Yes,
see,
sir.
I got an inclined force and I was unable to do anything. Now I resolved it, so I can do many things. So that's why we resolve. This is not of your use now. I just did it. Okay.
Sir.
This,
See,
Uncle
this
didn't
thing just
explain anything,
confused
but it's
me
fine.
more, sir.
forget
You
it.
said
Forget
you
it.
learned trigonometry. What?
Because it's a separate
Forget it.
chapter in math that you'll study further. You can't explain it in 10
Forget it.
minutes.
Okay, now see here. Even at this point, there will be force this side, this side, this side, this side, this side. Every direction will. What will matter? I'm just drawing that. So let us say force will be this side here, and it is increasing with depth, isn't it? But same force
Yes,
will be
sir.
acting upon this side also.
Oh, it will cancel out.
I said that, sir. I said that.
So lateral forces cancel out each other. No lateral movement. Understood?
Yes,
This
sir.
is physically what buoyancy is, right? And
Yes,
lots of definitions are required to explain the same thing.
yes,
Okay,
sir.
lots of definitions,
Yes,
right? I
sir.
hope you must have felt better with this theory.
Yes,
Nobody
sir.
tells this. Now, I'm going to answer that Sankalp's question, sir. When the body will float on the surface, when it will float inside the surface,
Sink.
suspended condition, or when it will sink.
studied
Okay,
last
so
year, sir.
what
Sir, I
You read
didn't,
last
I
year?
didn't
now.
ask that question, sir. I asked even gravity is like applying on the mass, right, sir? So, like the weight of the thing also matters, right, sir? The weight of the object also matters, right, sir?
Exactly.
So, like,
Now the weight is considering. Now we'll be considering the weight. Now see here. Now see here. Anybody will float only when. Anybody will float only when. See here.
Its density is lower.
Only when. No. When volume of liquid, or not volume, weight of liquid
Density.
displaced is equals to the weight of the body. For example, let us say that this is 10 meter cube, right, and weighs 10 kg. Agree? Let us say
Yes,
that.
sir.
So it
Yes,
will
sir.
displace 10 meter cube of water
yes, sir.
to
Then
get
it
Yes,
itself
sir.
adjust.
then they get like display. I mean,
Now, what is the weight of 10 meter cube of water?
10 kg
10 kg.
So 1 kg,
is
sorry,
equal to
1000
1.
No,
kg
it's 1000
per
kg
meter
per
cube.
meter cube.
1000 kgs per meter cube,
Sir,
right?
1 million kg, sir.
Huh?
Oh, yeah. No, no, sir.
Oh yeah, damn.
1000 kgs per meter cube, and it is 1 gram per centimeter cube. Always remember this. This is rho W, right? So 10 meter
Yes, sir.
cubes,
Yes,
that
sir.
means you just multiplied with 10, so it will be 10,000 kgs. Understood?
Yes, sir.
So in this condition, it will get enough buoyancy force and it will float on the surface like this.
And
Understood?
then oh, yes, sir.
Right. Now let me give you another
Sir, it's a
situation.
low. Sir, it's a lower sign, right? Sir, how is it equal sign? It should be a
What
lower,
sign is?
like a greater than sign, right, sir? Sorry,
No,
smaller
weight of
than sign,
it should
right,
be
sir?
equal. The weight of liquid display should be equal to the weight of the body.
Then it will be
No,
like in, if it is greater.
suspend.
No, see here, see here,
If
see.
it's equal,
Agree.
it should suspend. Yes, sir.
Yeah, if it is equal, it will be suspended. If it is greater, it will be inside.
So,
The thing
like
is that, for example, let us say now,
Sir,
let us say now, this is really small. This is really small. Let me increase the mass. 1 meter cube, 1 meter cube, and the weight is how much? 1,000 kgs.
So that's a bit too much, right, sir?
The 1 meter cube is again huge.
how
One
much?
meter cube. How shall I do it?
Sir, 1 meter
meter
cube is
cube
like
of water itself is
Of
1000 kg,
water,
da.
it's like 10,000 kilograms.
Yeah, 1 meter cube is again huge. Let me think about it.
The
I need to
0.01
I need to show you some calculations. I'm doing that calculation so that it becomes easier to calculate.
sounds like the
So
teaching problem.
I'm
right,
asking the weight of liquid displaced in this case, like 10 meter cube and 10 kg substance. In
okay,
that
see here.
case,
Now
it's
see
not
here.
equal, right, sir?
It's not equal. Now see in this case. So in that case, what the body will be upward. Body will be above the
so,
water. This will not be
sir.
the
So,
situation.
excuse me, sir.
Yeah.
Sir, so basically, you're saying if the row of that object is
No, no,
more
no questions
than
on this, Mister. Please. First, let me explain because I know all of your doubts. Okay, all of your doubts. So I just want three situations. I'm just creating those three situations, and then I'll explain it to you, and then I'll take the doubts on this matter. If another doubt is there, I can go for it. Is there
Yes,
any
sir.
other doubt?
Yes, sir.
Yeah,
Just give
so
me
one
two
small
minutes.
doubt,
I'll
like really
I'll
small doubt.
I'll clear everything. If it is on this, then please leave it.
Yes, sir.
Please, I'll just explain
Okay.
everything to you. Okay. Now see there. In this situation, the body is 1 meter cube and it is 1,000 kgs, right?
Yes,
So
sir.
yes,
it will
sir.
now the weight that has been displaced by the water is 1,000 kgs because the 1 meter cube if you insert, so 1 meter cube water will go out,
Yes, sir.
okay, and then it will be 1,000 kgs water, 1,000 kgs of that
Uh,
particular substance. And now
Yes,
it
sir.
will suspend because all of its volume should go inside, so that 1001 meter cube gets displaced.
Yes,
Are you getting
sir.
my point? I'll just give
sir.
you one more example and you'll understand
sir.
everything. Let us say that it is 0.5 meter cube. Or let us say that it is not 0.5 meter cube. Let us say that it is 2 meter cubes. 2 meter cube. And the weight is same, 1000 kgs. It may happen. Now
Yes,
see
sir.
very carefully here. See very carefully. Now you have 2 meter cube, okay, and you have 1000 kgs, right? If
Yes,
2
sir.
meter cube gets inside water, how much weight of the water will get displaced? So 1000 into 2,
1000.
2000.
2000.
2000 kgs.
kilograms.
Is that required?
2000 kg.
Not equal to 1000. So
Is
it'll
that
start.
required?
No, sir.
No,
For
sir.
example, if the body is applying a weight of 1000 kgs, 1000 g, and you are pushing it upward with 2000 g, is that required?
No.
No,
No, sir.
It'll go up. It'll start
right?
floating.
No, sir.
What will happen? What will happen? It will just try to displace the volume equals to its weight. So if it just gets 1 meter cube inside and 1 meter cube above, 1 meter cube above and 1 meter cube inside, then what will happen? Will it be able to displace
Will be
1000
balanced.
kgs?
Yes, sir.
Yes, sir.
And will it be floating?
Yes.
Yes, sir.
Yes, sir. Almost. Yeah.
Now understood
Yes,
the
sir.
condition between the floating and the suspended situation. Let us
Sure.
take one more example. Let us take one more
Yes,
example.
sir.
Let us say that it is 4 meter cube and same 1000 kgs. Now what
Like
will happen?
4000 kilograms of
1/4
So
of
it
the object will be down.
4000.
exactly 1/4 of the object will be downwards so as to get the weight of the liquid displaced equal to its volume, and the rest 3/4 of the body will be floating upwards. Now see how light this body is.
You'll keep
4
doing like that.
meter
5 meter
cube.
cube means 1/5 of
Something
the.
like a plastic, something like cotton. You see all of the part of that volume above this water surface and very little downwards. Why? Because that is enough for displacement of its weight equals to the volume of water. Say yes or no. And is all of your doubt cleared now?
Yes, sir.
Now, even if, let us say one more situation, even if the weight is 0.5, so the weight is 1000 kgs and the volume is 0.5 meter cubes only, highly dense, isn't it? High density, less volume, more mass.
Yes, sir.
Yes, sir.
Will it sink because it won't be able to
Like accommodate with
displace?
the displacement. Sir.
What maximum displacement can it do? Maximum displacement it can do is for 500 kgs only. 0.5 into density. Density is mass by volume. So if you multiply mass, rho into volume will give you mass. So rho is what? 1000 into 0.5 volume will give you 500 kg. So with that condition, water can sustain for 500 kgs only with this particular volume. But you have a mass greater than that. That means Earth is attracting more. So it will sink down. Understood?
No, sir. I actually don't get it.
Last part
Dialogue.
alone,
Yes,
because
sir.
you told it too fast.
I
Okay, see.
don't get it, sir.
See,
He told a bit of a
what I
system.
did, I took a body of volume 0.5 meter cube and the mass was same 1000 kgs. How much mass it can displace 0.5 meter cubes? So 0.5 meter cubes, when it's multiplied with the density of water, it can displace only 500 kgs. Yes or no? Right? But what is the mass of that particular body? That is
It's 1000 kgs.
So I'll sing.
1000 kgs. So isn't that weight more than what water can sustain?
Yes, sir. So,
Yeah.
okay. So it's
Sir, but how do we know that 0.5 meter cube can displace only 500 kilograms, sir?
Because we know the density of water. That's what I wrote. Density is what? Mass per unit volume.
1000.
Isn't
Sir.
it? Density is mass per unit volume, and according to the law of flotation, what do we know? We know that a body floats only when weight of the liquid displaced is equal to the weight of the body. So how much weight of the liquid displaced? What was the weight of the liquid? So weight of the liquid was rho into volume.
100
Rho of
kilograms.
liquid is 1000. Volume we know that's 0.5 meter cube. So that it can displace only 500 kgs of water. So 500 kgs of water should be equal to the 500 kgs of mass that you have put into, isn't it?
Yes, sir.
Yes, sir.
But that was not so, because we had a mass of how much? 1000 kgs.
So
1000
1000.
kgs.
Understood?
Yes, sir.
Yes, sir.
Sir, so can
This
you
is
explain the 4-meter cube which applies?
let us say,
Can you?
give any situation 4-meter cube for 1000 kgs.
Yes, sir.
Okay, that's we did. Where were you then? We
No,
did it.
no, sir. I was still thinking of the 2-meter cube, and you finished the 4-meter.
Same
Okay, see
thing,
here,
right?
see
Sir?
here,
Like
see. 4-meter cube and 1000 kg. Step number one. I'll go stepwise. Step number one. How much weight of water this 4-meter cube can displace? Right? You must have seen now when you put hands in your bucket, the water rises up, isn't it?
Yes, sir. Yes, sir.
Why that? Because the water got displaced equal to the weight of your hand, isn't
Yes,
it?
sir.
Equal to
Yes,
the
sir.
volume of your hand. Whatever volume your hand occupied in the bucket, that much water it rose,
Yes, sir.
right? So 4
Yes,
meter
sir.
cube, when you will put it inside, how much water it will displace? So density is what? Mass into mass by volume. So how much water, mass of water? That will be density into volume. So density of water is 1000. Volume that we have to put it inside is 4 meters. So it can displace 4000 kgs, right?
Yes, sir.
So 4000 kgs displacement means the water can hold up to 4000 kgs with that particular volume. With that particular volume, water can hold up to 4000 kgs. But how much mass you have
1000
got?
kilograms.
How much mass you have
1000
got?
kilograms.
1000.
1000 kilograms. That means how much that body has to go inside. So that body just has to go inside 1 meter cube because 1 into 1000 is 1000. That will balance this body, right? So it will just
Yes,
go
sir.
1 meter cube inside and the rest 3 meter cube will be seen by you floating. That is the concept. Understood or
Yes,
not?
sir. I get it, sir. I get it, sir.
Everyone tell me, understood or not?
Yes,
Definitely
sir.
Yes,
understood.
sir.
Sir,
This is the practical application. I
certain
taught you
things
this beyond
like
the books. Beyond the books. Now we'll be working with the formulas, right? And I think I have explained up to you for all of the chapters, I guess.
Yes,
yes,
sir.
sir.
Whole of the chapter I've explained it to you, right? But we just have to do the questions and the definitions. That is most
So,
important.
so the more the volume, more light it is.
Exactly. So whatever mass we have to uh, hold inside the water, what conditions do you think you have to put? Sankalp will tell first. Sankalp, how do you think we can hold a body inside a water, floating on the water, floating on the water? What
Sir,
should we
if the
think if you want anything to float and mass is constant?
sir, the volume of the object should be less, and like how much it displaces should be more, sir.
Volume should be more, now.
The volume of the object should be less, and how much it displaces should be more. Like 0.5 meter cube means it's very small, but 4 meter cube is very big.
How does that matter? It is not we need exactly. If it is more, it will be floating. So
Sir,
volume
if
should
it's
be as
more,
more.
if it's more, it will be floating. If it's less, it will be like it will
Sinking.
sink in. Yes, sir.
So if I'm asking you, what conditions would you put if I need something to float on the water? Let us say that we don't have that ship. Now let us assume that the ship has not been built. We have nothing called like boat or ship. And we just discovered this law in this meeting itself. Okay. So now I am putting forward in this meeting that we need to develop something that can float on water. What you as a young scientist will think about? What ideas would you put forward?
Increase the
Sir,
surface area, like volume.
Uh,
Sir,
Sir, I
find
increase
a
the
low
volume, sir.
density substance
No,
and
I'll do it.
find the same
Find a low
density
density
water,
substance which
sir.
has much volume, such as plastic.
But we cannot row the
Sir,
plastic.
Anything that
1
is like
meter. Hey, wait 1 second. So 1 meter cube of an object should displace the 1000 kilograms, which will be equal to the density of water, sir.
See,
So
you
it
are
I'll
will
only
stick
be
to that
suspend it.
particular
I'll only
thing.
Thinking
suspend
about
it.
what
I'll
we
just
did
float.
now.
You
Sorry,
are
sorry.
stick to that thing. See, don't be stick. See here, see here. You have understood it partially. Then, if you're saying this 1 meter cube is required, you have understood it partially. See, the thing is that if it is 4 meter cube, okay, if it is 4 meter cube and the mass is 1000 kgs that we have to suspend, right? So we need 1 meter cube of it to get down, and rest is really floating upwards. We are
Yes,
designing a
sir.
ship. We need to go up. If it is 1 meter cube only, then it will be balancing. 1 meter cube will be balancing, isn't it?
So
Yes, sir.
Right? So that will sink. That will be suspended inside it. That will be partially inside the water.
yes, sir.
Yes, sir.
Then how can we go with that? What you need to say is that, sir, whatever mass you say, we can carry any mass. We can carry any mass. Just we have to design something like that. Whatever weight it carries, it displaces that weight. Yes or no?
Yes, sir.
Now let me change the numbers because you are now obsessed with the numbers only.
The
Now
7.
see here. Now see here. Let us say that we have 7 meter cube, and whatever mass you say any mass you say. Sankalp is
500.
the mass.
2000.
500 kgs, right?
Sir,
Yes,
isn't that
sir.
the weight of water, sir? Isn't that fixed?
Pardon?
Isn't the weight of the water fixed, sir?
No,
Like
we are
how
not talking about the weight of water. We are talking how much 7
This
meter
is the
cube
object.
displaces.
No, 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 no. I'm just talking about taking any object. You take
the
any
object
object
can
of
be
any
500
volume and any
kilograms.
mass, and we'll see that how much it floats.
Yes, sir.
So say any volume,
Sir,
Meter
7
cube.
meter cube.
7 meter cube, any mass of that particular volume. Assume anything.
5. Sir, 750
Hey, tell me the
kilograms.
closest 100, ra.
Sir, 800, sir, 800.
Okay,
700.
okay, no problem. But let it be 750 only. Just little bit of calculations will be required. Congo, are you there?
I think he's
Yes,
muted.
sir.
There's something technical issue.
Yes, that's it.
Congo,
Technical
are you there?
Wait, just now unmute.
standby.
Sir, yes.
Are you understanding everything?
Yes, sir, I understand it, sir.
Okay,
I don't have any
good.
doubts.
So now, density of water is what? 1000 kgs per meter cube. Like in
Yes,
1
sir.
meter cube, it is 1000 kgs. So
Yes.
I need to get something equal to the weight of 750 kgs. So 1000 into how much volume will give me 750 kgs, right? So X will be 0.75 meter cube. Yes or no?
Yes.
Yes, sir.
Density into volume is mass. Volume I don't know. So that means I need 0.75 meter cubes of volume to balance this weight. Yes or no? Inside the water, right?
Yes, sir.
Sir.
So it will be now what? So just of 7 meter cubes, 0.75 will go down and rest 6.25 will go up.
Yes, sir.
That's it. It will float.
Yes, sir.
But you know what is 7 meter cube?
Yes,
7
sir.
meter cube, sir.
You know how much it is?
Yes, sir. It's like 2 floors.
Now, what is the length of your bed? Okay.
Something
King
like
Or
size.
that.
A king size.
Something
What
like
about king size?
2.5 meters, sir.
no, or you can
Yeah.
take it to be half of your room. You think that half of your room will weigh only 750 kgs?
No, sir.
Sankar will itself weigh more than 750 kg, sir.
No, no. 750 kgs is more than that. See, I'm giving you something. I'm giving you something. Let us take exact density of this iron.
Yeah,
Let
like
me search density of iron.
just take a density of the Titanic, sir. Just search it up, sir.
That is density of iron is 7874 kg per meter cube. Okay,
Yes,
this is
sir.
density of iron. That means in 1 meter cube, this is the density. So you think if you have 7 meter cubes, how much will be the density? 7 times of this, right?
7 into
Yes,
7,
sir.
8, 7, 4.
So that means, let us say that we have 10 meter cubes of iron box, something like this, 10 meter cubes, and that weighs around that has something inside it also, so that may weigh around, let us say that 10,000 kgs. 10,000 kgs, right?
Yes, sir.
So let us say that for carrying 10,000 kgs, how much volume do we require? So this is 10,000 now. So we require how much?
10, sir.
Okay, 10. So what does that mean? That
Sir,
means
that.
all of it has to go down like
Yes,
this.
sir.
All of it has to go down.
Yes, sir.
Yes, sir.
Understood? But it
Yes,
will not
sir.
sink. But it will not sink.
It is suspended.
Sir, that means we can see the surface, the top surface of the object.
This condition and this condition are in equilibrium. You cannot say about this.
No,
That's
sir.
like
I
perfectly
no.
floating. It's
Yes,
not
sir.
floating.
I'm saying the top. I'm saying the top of the top
Not
Give me
surface
touching the
1
of
minute. Give
ground.
me
the.
1 minute.
Not
What?
Like touching to the top ground or
Yeah.
top ceiling. It's like touching
Yeah,
the
that's what
ceiling.
I'm saying.
Ah,
Like
yeah.
the top
perfect.
surface of the
Like you.
top surface of the object should touch the top surface of the water.
Hey, Conwell, no
See,
one is perfect.
the
No.
ideal condition is this. The ideal condition is this. But you may find that generally the bodies are like this only. That has
Other
a particular
factors.
reason. That
Other
has a
factors.
particular reason. Other factors like silt may deposit on its surface. Okay, some extra
Rust.
weight may get added on it, rust and
Rusting.
whatever is there. So that may not lead to its sinking, but may lead to like somewhat displacement downwards.
Yes, sir.
Okay. So now,
Yes, sir.
did you understand this chapter?
Yes, sir.
Chapter over.
So that's it.
The chapter is over, but we will be working 2-3 more classes on it with for the what do we say that definitions and all. Okay,
So
this
you
was
said
all the
we have
theoretical part.
many. You said we have many
What is
numericals in this.
Archimedes principle? What is
Yeah, all those things are dependent on this only. Whatever theory I told, this theory was the main thing. Nobody in the whole world is going to teach you this. Okay, I like teacher just used to explain Archimedes principle, just to explain what is buoyancy with the definition, whatever is floating with the definition. Okay, body is floating because of its. They may say that the body will be a body floats only when it displaces the volume equal to the weight of the body. So, but the thing is that practical situation, no one will tell you, and this is the most practical situation that I had devised. Okay, so I hope you must have understood all these things, right?
yes,
Yes,
sir.
sir.
Yes, sir.
Now it would be easier for me for making you questions and answers, and you may think practically how it would work while working with the formulas, isn't it?
Yes, sir. So why you not a
Yes, sir.
school teacher, sir?
I don't want
Because
to
he's
be a
not in
school
Has
teacher.
study.
better jobs than teaching ungrateful children like us.
Because sir's studying in college. How can he be a school
Yeah.
teacher?
A part-time job.
Okay.
It's a
Sir.
not part-time.
I am doing a part-time job, but I like this. It's my passion to teach.
Sir, you
Sir,
forgot
I've been
like,
teaching when I was.
homework.
I've been teaching since my class 11th.
It's my
10th.
time to
Yeah, when I
shine.
was in class 11th, I started teaching. I got the result of my boards, and it was
Different,
good.
sir.
And all of the people of my neighborhood called myself to teach their children.
Teach me, please. Teach my son.
If you teach, you'll understand
From
the
then,
subject better.
Stupid doing
I started
Minecraft
it.
all day.
sir, it's like a
Hey, you
scholarship
forgot the
for your
homework.
college, sir.
Sir, about the
Right?
movement.
What the homework?
About the movement of
Pardon?
objects underwater.
Sir, uses of barometer to predict the weather. Okay, let Tarun speak. Hi, Tarun.
If
Tarun,
a
speak.
gun is fired underwater, sir, if a
I
I could
gun
not
is
hear you.
fired, sir, if a gun is fired underwater,
Yeah,
the bullet won't travel for a long distance.
exactly.
Then when it falls, sir, as soon as the gun exerts pressure on the bullet, it goes for some distance, but will it fall in slanting direction or in like straight direction?
Fall and slanting direction according to the force, but after some time it will go like
Depends upon the
Slant
the center of mass of the bullet is.
liquid also. What type of liquid you are using?
uh,
Density.
Yeah.
How much hard that density is?
Inside the
Being
water, sir, like
non-practical.
inside sea.
inside sea.
Inside sea. Inside sea. Then in case of water, it is I think it should go in a slanting position. But after that, after little bit slant will be seen there. Very little
It'll
slant.
be like a curve. So
Because if
it'll
it
go
has
like this
reached,
and then curve and then straight fall down.
But if the
then it
bullet
will
is
go like this.
perfectly balanced, like it'll be
Happens
perfectly
that
Like
the
how the
drag
balanced.
balance
force in case of water is more. The drag force that you'll experience in case of water is more.
it's like
Yes, sir.
when you're running trying to run with an umbrella behind your back. It'll be like Sankal's in the future holding him back.
Okay,
Yes,
Yes,
that's all
sir.
for
sir.
today. I hope you
Sir,
liked the
Thank you,
session.
sir.
sir,
Very much
so
Yes,
so.
sir.
That
Yeah.
suspense was amazing.
sir, like,
You.
sir, all these
Thank you, sir.
laws
Bye, sir.
differ from planet to planet because they have different gravity rates, sir.
Yeah,
You don't even
Martian
Exactly.
have
study
water. You don't
physics.
even know which planet has water. What are you talking about?
No,
I don't
it's
have studied about different planets because nobody has studied that.
Martians study physics instead of physics because they don't know
What's
physics.
photophysics?
There's no only Martians study that.
Oh, what does the Martians mean? Like aliens stuff?
Or they are
wait,
expected to be people living
Oh,
in
I just
Mars.
had
yeah,
that
I,
one. Just that had that one movie named The Martian. That
sir,
was a man
So
stuck
many
in
like
Mars.
common
After
names,
seeing
sir.
Interstellar, I didn't sleep for 3 nights for some reason, sir. Oh my, what is that
Okay.
black hole in the middle of our
Go for
galaxy?
Martian.
Or something like
Go
that.
for The Martian. That is a good one.
yes,
The
sir,
Martian.
Martian's better. Martian's better.
I didn't watch the
Hey,
movie, but
Men in
Martians is like
Black
a
is
common
better.
name.
Sir,
Then shall we
Martian
keep
is
it?
that movie where he gets abandoned and eats potatoes, right, sir?
Yeah. He lives in Mars.
It's
Physics.
Very
actually
good
the
Okay
movie,
guess.
then.
yeah.
You open up
Bye
Netflix
everyone.
just to see. It's
Thank
a
you.
a
Yes,
story
sir.
about
Thank you,
a
sir. Bye, sir.
Bye.
Thank you, sir.